Hello, welcome to my group's presentation for group 61 with our project called Is My State Addicted? How our system works is that we store data from the 1,000 points of current drug addiction data, and we use it to extrapolate the specific substance and state data for the inputs that we put into the original menu. So as an example, we'll show you if we select every option, right? We can start with California. And how our input system works is that if we misspelled, even though as much as we want to click enter, it will not accept it. So once we eventually get to the point where we spell the name right, it'll broadcast the state map representation on our right screen. And once that is on our right, we know that we have the specific data for California secured. And same thing can be said for the different substance options. Like for alcohol, if we click the yes option, we will see that boom, it poops up into the right, which knows that we will specifically take in the alcohol options. Same thing for hard drugs, and same thing for marijuana, right? And for the age groups, like if we want to determine data for a certain population, we would also just do the same thing. And we can see later on that there is no fallacy if we want to select specifically like hard drugs or marijuana or specific age groups, because all the data is comprised into different lists that for each specific group, even though that we have the large pool of original data. For our first example, we'll do a map implementation since we're comparing the two. The hash implementation should be a little bit faster as we are using rehashing to access the data and to store the data instead of searching through the entire map list that the map data structure list that we created. And for the first example, we're going to use the max heap implementation that ranks the different rates from greatest to least. So with these selected, we should get our results. And in our results, we can see that every different age group and every different proportion is ranked per 1,000 years. We chose to choose years from 2010 and up, as these are the most recent data points, and 2017 being the last data point that was available to us in the original document. With the greatest to least, we can see how recent a problem is for a certain state. Let's say you are a 18 to 25-year-old who smokes weed in California. We could see that the ranking or the percentage of per 1,000 people is 27%, meaning that this year is the greatest proportion of the population of people who smoke weed, meaning that there is a growing trend of people who are smoking in that state. The same thing could be said for, let's say, actually the opposite can be said for hard drugs, as the proportion of hard drugs is actually decreased for the youth, meaning that they are doing proper measures to decrease that, and their measures are being successful. So let's say you're a government official and you're looking at the data. With this, you can know what strategies you're doing and how the strategies are working. So now let's do another example with different selections. We'll do a different state, like Florida. Boom, the Florida map is showed, so we know that we're doing the right thing. Instead of, we want to know about more of the alcohol problem in Florida, right? We would just select alcohol and nothing else, and for all age groups. With a hash implementation from least to greatest, meaning with this selection, we'll know if the trend of alcohol is reducing or improving for the youth of our state. And as we can see, the rate for 18 to 25-year-olds is actually decreasing, which is a great insight that we can from this expression of data. Now let's do the same thing with let's do Nevada, showing that we can do any state that we select with all the options, but specifically for the older generations with the hash of least to greatest. And boom, it only expresses the data we need and the data that's available, with it filtering out years previously or years that are irrelevant. And since the data was only stored up to 2013 for that certain entry, we can only use that data. But I still think that is relevant enough, it was still in place. And with that, that should be all of the features, right? We can rank latest to least, least to greatest, every single substance, and with a map or hash implementation. I hope you enjoyed the project and have a good day.